Okay, today we're dealing with oblique triangles, section 3.4 in your book there, okay? Oblique triangles basically are those ones that have no right angles in them, okay? No right angles. So naming them again, the sides are opposite the angles, right? So angle A, side A, angle B, side B, angle C, side C. All three angles add up to 180 degrees. Now, when we're solving triangles, what that basically means is that we need three pieces of information. Well, to solve them, sorry, it means that we're looking for all the angles and all the sides, all right? So we need three pieces of information for that. It could be either two angles and a side, and there's two different scenarios, right? What these look like is angle, angle, side, and angle, side, angle. So it could be any combination, but basically when the side is not between the angles, okay, it's an AAS. If the side is sandwiched between the angles, it's an ASA. Now, these are pretty much moot because if you have any two angles, you can always find the third because they all add up to 180, all right? Now, another situation is two sides and an angle. If you had two sides and an angle, it could be SSA, so you have a side, and then an angle, right? SSA. Or you could have a side, a sandwiched angle, and another side. So this would be SAS. These are just different types. They're not really that, I mean, they're important, but we're going to figure out different ways to solve these. I'm just sort of giving you some background about the types of triangles. And you could also have three sides, okay? So if you have any three sides, you can find out all three angles doing some basic trigonometry, okay? Now, I guess a question I could ask you is, well, why wouldn't three angles work? Well, hopefully you understand that if you have three angles, what's not clear is how big the sides are, because you can make tons of different triangles, all that have the same three angles, but different length sides. So we need at least one side to get a reference to solve these triangles, okay? Now, let's look at a couple of examples here. Given triangle ABC, how would we solve for angle, find those other bits of information? Now, I suggested to you guys before when we did these, always draw yourself a baseline, okay? Angle 30, we'll put that A here, angle 30 degrees. We'll put the longer side on the bottom. That means if that's side B, that's angle B. And then we'll put 8 down here, maybe. Let's make that a little bit shorter. Let's go like this, and we'll call that 8 there. Because that's not 8, sorry. If that's that's angle C, that's angle side C there. So what we have here is a triangle that we've generated. You might generate it a little bit differently, but it's good to give it a shot a few different ways. So angle A 30, side B 10, side C 8. Okay, now we don't have any right angle triangles here. So the idea is, in this first dealing with oblique triangles, is generate a right angle triangle. And now you know a couple different things. You know that this whole thing is 10. So if you call this little bit x, and this little bit, well, let's call this bit x here, right? That means that this one is 10 minus x. So we have a few different things that we can find. We have a right angle triangle on this side. Sorry, let me cover it up. We have a right angle triangle on this side. So if we deal with that one, why don't we just look at this and say, okay, well, why don't I find the height? Why don't I find that bit, right? Let's find the little pieces of that right angle triangle. So if I go sine of 30, that's going to equal h over 8. And if I want to find x, I can go cos 30 is equal to x over 8. And I can find h and x pretty quick here. Just take out the calculator, right? Let's look at this now. So make sure I'm in the right mode. Let's turn it on first, put it in the right mode. I'm in degrees. So I'll go sine 30, boom, and I times it by 8. It gives me h of 4. Here, I'll go cos 30, and then I'll go times 8, and it gives me 6.9. Well, now I've got 6.9 here. I've got 4 here. If this whole thing is 10, that's 6.9. That means that this has to be 3.1. And now if you look here, you have a triangle where that's 3.1, that's 4. Well, we can find this side right here, right? by doing Pythagoras. So 4 squared plus 3.1 squared is equal to y squared. So 16 plus, let's go, 3.1 squared plus 9.61 is equal to y squared. Let's add 16 to that. Let's take the square root of it. That means that y would equal 5.1 now. Okay, so I've got this as being 5.1. I've got the height here of 4. I don't have this angle. Let's find that angle, right? Opposite and adjacent. So we can go tan theta is opposite over adjacent. And we've seen this before, right? We go second tan, 4 divided by 3.1, and we have 52.2. So 52 degrees, let's call it. So this here would be 52 degrees. And then we have 30 and 52 is 82. So that leaves 108 here. Wait a second, 98, sorry. 98 here. Okay. Yeah, so let's have a look. So that means that we have angle C we found to be 52 degrees. Angle B we found to be 98 degrees. And side A we found to be 5.1. And we've got all the little pieces for our question. Okay, now if that's confusing, I apologize. I will definitely make it clearer in class. Let's try, I got a couple more questions here. Yeah, 2 more, so let's have a look at another one. Given ABC, I got 3 sides. So let's see if we can generate, let's put the longest side on the bottom, right? 12. Let's go 10, and let's call that one 8. So 10 and 8. You got to make something. I don't know how it's always going to work. Yours might look differently. So C, so that's got to be C. 10 is B, and that's A. Now, I need to find the angles. Well, again, we've set it up in a way that allows us to draw a right angle triangle. Now, you know that the whole thing is 12 here. From there to the other side, from A to B is 12. So if we call that X, that's got to be the remainder, 12 minus X. And we've got a similar leg or a similar arm in both of these triangles called H. So if we look at the left side here, okay, let's slide this up. Left side, we got X squared plus H squared is 10 squared. This side, H squared plus 12 minus X squared is equal to 8 squared, right? So here, H squared is equal to 100 minus X squared. Here, H squared is equal to 64 minus 12 minus X squared. Now, at this point right here, ladies and gentlemen, you should notice something. They're both equal to H squared. And if they're both equal to H squared, what we can do is make them equal to each other. So 100 minus X squared is equal to 64 minus, let's expand this, 144 minus 24X plus X squared. Okay, 100 minus X squared is equal to 64 minus 144 plus 24X minus X squared. Now, the algebra is involved here, folks. The X squareds go away. See if you can solve this on your own. Okay, I'm going to end up with 24X on this side, and it's going to be, let's have a look, 100, right? I'm going to subtract the 64, and then I'm going to add the 144. So I end up with 180 is equal to 24X. Divided by 24, you get X is equal to 7.5. So that means that if this is equal to 7.5 here, this side here has to equal 4.5. Okay? X squared plus bingo. Yeah, okay, so we're doing okay here, I think. So now, if you look at this thing, I've got 2 different triangles. Let's take this one out here, right? If that's 10 and that's 7.5, I could find, oops, sorry. If this is 10 and that's 7.5, I can find that angle, right? And similarly on this side, if I take this triangle out, right? That's 8, that's 4.5. I can find that angle. So here, cos minus 1 of 7.5 over 10. Here, cos minus 1 of, 4.5 over 8. So let's do this one first. I just realized that's off the thing, so let's do these one at a time. Second cos 7.5 divided by 10. That gives me 41.4 degrees. So this one is 41, let's just call it 41 degrees, okay? Now let's look at the other side here. Second cos of 4.5 divided by 8, we get 56 degrees. So let's call this one 56 degrees. And if we go 180 minus 56 minus 41, we end up with 83 degrees up here. So what we have is angle A is equal to 41 degrees. Angle B is equal to 56 degrees, and angle C is equal to 83 degrees. All right. Now, we've got one last question here to do. Let's have a look at it, see if we can make some sense out of this last one. Given triangle ABC, again, always start with your base, okay? Put this angle, what do we got here? Let's put the angle 20 down here, right? So we'll call this B, make that 20 degrees. All the triangles that we draw kind of look like this, so why don't we put the 110 up here, make it a little bit easier for us. We'll call this angle A, that means that this is angle C, and they said that C is 10. Okay, now there's a lot of information here. If we were going to draw our line down here, it breaks this angle up into two pieces. Now I don't know that angle. Can I find this angle? Well, we know that all three add up to 180. 20 and 110 is 130. I got 50 degrees here. And now all of a sudden it becomes relatively easy to do. I don't need this angle up here, really, right? But what I have is two triangles. I need to find this side right here, and then this side here, and then this side here. So this will probably help me. How about sine of 20 is equal to h over 10? If I want to find this, it will be cos of 20 is equal to x over 10. So in each of these cases, folks, give it a shot, find out what that h and x are. Let's see if we can do it together if you don't know what's going on. So sine 20 times 10, this is 3.4. Okay, cos 20 times 10, 9.4. Okay, so what we have here is 3.4 for my height. This is 9.4 here. I have an angle right here. Now I've got a triangle here where I can solve for the z and the y, right? So let's solve for the y first. So it's going to be tan 50 is 3.4 over y. Right, now how do we solve this one? The y is on the bottom, so in this case we do a division. It's 3.4 divided by tan 50. That gives me 2.9, so here y is equal to 2.9, so we'll put that in here, 2.9. The last thing we have right up here is z. We can use Pythagoras, 3.4 squared plus 2.9 squared is equal to z squared. We can use cosine, adjacent hypotenuse, and we can use tangent, opposite over hypotenuse, or sine, sorry, opposite over hypotenuse. That might give you a little bit of a different answer because we've rounded them off, but I'd say it doesn't really matter which way you do it. So sine of 50 is 3.4 over z. So in this case, again, 3.4 divided by sine 50, and we end up with 4.4. Okay, z is 4.4. So, well, I guess we could call them all these. So anyways, angle C is equal to 50 degrees. We had B being this side here, which we called Z. We've got Z as being 4.4, and we've got A as being 9.4 plus 2.9, so 11, 12.3. Okay, 12.3. So another type of triangle that we're going to have to solve. Let's figure this stuff out and we'll continue on later. Bye.